Next sum. When 6.3 grams of sodium bicarbonate is added to 30 grams of acetic acid solutions, 30 grams of acetic acid solution, the residual solution is found to weigh 33 grams. And now a sodium bicarbonate formula is NaHCO3. Sodium bicarbonate is added with acetic acid. Acetic acid formula is CH3COOH. It gives a residual solution is found to weigh 33 grams. So residual solution means sodium bicarbonate and acetic acid forms sodium acetate plus water plus carbon dioxide. The residue contains sodium acetate plus water molecule. The residual solution is 33 grams. 6.3 grams of sodium bicarbonate, 30 grams of acetic acid. These two are interacted to form a 33 grams of residue. The number of moles of carbon dioxide released in the reaction. They are asking about a number of moles of carbon dioxide. Now we have to find out the mass amount of carbon dioxide is liberated from this reactions. The weight of the reactant is 30 plus 6.3, 36.3 grams. Residue is 33 grams. So we have to subtract the residue value from the reactant value. We can get a 3.3. This 3.3 grams of carbon dioxide is released from this reactions. They are asking about the number of moles of carbon dioxide. That is, moles means mass divided by molecular mass. The given mass of carbon dioxide is 3.3. The molecular mass of carbon dioxide is 44. The answer is 3.3 is divided by 44. The answer is 0.075. So, the number of moles of carbon dioxide released in this reaction is 0.075. The next question. When 22.4 liter of hydrogen 22.4 liter of hydrogen mixed with 11.2 liters of chlorine, it forms 2 moles of HCl. So 1 mole of hydrogen interact with 1 mole of chlorine, it forms 2 mole of hydrochloric acid. The question should be when 22.4 liters of hydrogen is mixed with 11.2 liters of chlorine, each at 273 Kelvin at 1 atmospheric pressure, the moles of HCl. They are asking about moles of HCl. Here 1 mole is equal to 22.4. Now we are getting product as 2 moles. 1 mole is equal to 22.4. 1 mole is equal to 22.4. 11.2 means 0.5 moles of chlorine only involved here. And now we are getting 2 moles. So 2 moles of hydrochloric acid. 2 moles means 2 into 22.4 hydrochloric acid we are getting. And they are asking about HCl. 1 moles of the moles of HCl is formed is equal to 1 mole of HCl is equal to, in that case they are asking about only 1 moles of HCl. So 0.5 moles of hydrogen interact with 0.5 moles of chlorine, it will form 1 mole of HCl. So answer is 1 mole of HCl. In this sums, they are giving only 0.5 moles of chlorine. Then only 0.5 moles of hydrogen is react together to form 1 mole of HCl. So answer is 1 mole of HCl. Then another question. Hot concentrated sulfuric acid is a moderately strong oxidizing agent. Which of the following reaction does not show oxidizing behavior? That is, oxidation means the loss of an electron is called an oxidation. Here copper, the element in free states, the oxidation state should be in a 0. In this case, the oxidation state of copper is +2. So the oxidation status increased from 0 to 2. That is, if the oxidation number is increases, that process is called oxidations. So copper undergo the oxidation. Now the question is, which of the following reaction does not show the oxidizing behavior? Then second, we have to check each and everything. They are asking which one does not undergo the oxidations. Then B, carbon. Carbon a free state. Oxidation number is 0. Here the carbon the oxidation number is +4. So oxidation state should be an increases. The carbon also undergo the oxidations. Then barium chloride. Here barium chloride oxidation number is +2. Barium sulfate, here the oxidation number is also +2. So barium does not undergo the oxidation as well as the reduction reactions. Reduction reactions are here. So answer is a C. Because in reactant side the barium is also maintain a oxidation state +2, and product side the barium sulfate is also maintain oxidation state +2. So it does not undergo the oxidations. The question is, which of the following reaction does not show the oxidizing behavior? So answer is in a C. Another question. Choose the disproportion reactions among the following redox reaction. Disproportion reaction means only one of the reactor undergo the oxidation as well as a reduction. That type of reaction is called a disproportion reactions. So in this case, we know that disproportions means the reactant side, the reactant only involve the oxidation as well as in reductions. Reactant side we can get in only one reactant, but product side the same reactant has a different oxidation state. Oxidation states because the same reactants undergo the oxidation as well as in reductions. Now choose the disproportion reactions among the following redox reaction. Here magnesium is a 0, and now this here the magnesium is 2 plus, it's undergo oxidation reaction only. Disproportion means the element undergo oxidation as well as reduction reactions. Then B, phosphorus free state, so 0 in phos mean the phosphorus has -3 state. Phosphorus undergo reduction here. Then sodium dihydrogen phosphate, here the oxidation state of phosphorus is sodium is 1, hydrogen is +2, phosphorus considered as a X, -4 equal to 0, X -1 equal to 0, X equal to +1. Here the phosphorus undergo the oxidations 0 to 2 +1. So in the case of B, phosphorus undergo the reduction as well as an oxidations. This type of reaction is called disproportion reaction. So answer is B. In this case, we have to identify the equivalent mass of potassium permanganate. Equivalent mass of potassium permanganate is a very good oxidizing reagent. Equivalent mass of oxidizing agent equal to molecular mass of an oxidizing reagent divided by a number of electrons accepted or number of electrons released. This formula is very much helpful to calculate the equivalent mass of potassium permanganate. By using this formula, we have to easily calculate the equivalent mass of potassium permanganate. Equivalent mass of potassium permanganate is nothing but 52.7. That is a formula for equivalent masses. Molecular mass of an oxidizing reagent divided by the number of electrons accepted or the number of electrons donated. This formula is used here. Then which one of the following represent 180 grams of water? 180 grams of water means mass of water is 180. Molecular mass of water is 18 into Avogadro number Na. Avogadro number is 6.022 into 10 to the power of 23. 18 crashed 6.022 into 10 to the power of 24. Which of the following represent 180 grams of water means? Answer is 6.022 into 10 to the power of 24. Answer is D. Next question. 7.5 grams of gas occupies a volume 5.6 liters at 0 degree centigrade and 1 atmospheric pressure. The gas is that is, we are following the same formula. Mass of a gas is 7.5. The molecular mass, we didn't know the molecular mass as into which is follow the standard temperature pressure. So 22.4, 7.5 gram of gases occupies the volume 5.6. Now we intercross the both. 7.5 divided by 5.6 into 22.4 equal to molecular mass of given gas. Molecular mass of given gas, which is almost equal to, molecular mass of the gas is almost equal to 30. Now we check which gas molecular mass is 30. Now first I check NO. Atomic mass of nitrogen is 14 plus atomic mass of oxygen is 16. So total molecular mass of nitrous oxide is 30. So answer should be in 30. Formula is mass divided by molecular mass. Here they are asking about liters. So at the same time they are giving in a standard temperature pressure. So I put in a 22.4 here, and the volume occupied by 7.5 mole of gas is 5.6. 5.6. So I put a equal to 5.6. Then intercross it. I find out the answer is 30. It is a molecular mass of the gas. The below gases, among the below gases, nitrous oxide and nitrogen monoxide only have a molecular mass 30. So answer is an A.